Hey, what's up? In today's video, we are going to look at how to create OpenShift apps from base elements. When I say base elements, what I mean is you'll be creating OpenShift apps using existing resources in system like pods and deployment configs and other basic elements. You won't be doing it via the UI or the web console or using there's a command called OpenShift OC new -app. We won't be using that. The reason why we are doing this is we want to know what is happening behind the scenes when you create a new app or when the system provisions a new app for you in the cluster. So I'll be doing this in a Minishift cluster. We are booting this cluster in my laptop as we speak, and once it is booted, you'll have to make sure that you have the OC command running. OC is the OpenShift client. This is used to interact with your OpenShift cluster from the command line. You can download OC from the OpenShift site. So I'll just put the link here. You can download it for your operating system from this page, okd.io/download.html. So once you download OC, you'll have to configure OC to make it work with your cluster. So the way you do it is to log in your cluster from OC. The cluster gives an easy way for you to do this. So you can just go to the cluster. You can see that this is my Minishift cluster. And I'm not sure what the login and the username for this is. Let me try admin. Okay, whatever you give, it's going to log in. So once you log into your cluster, you should see a dashboard like this, and then you can copy the login command from over here and then paste it in your console. It looks like this: OC login, the top level domain name of your cluster, and then a temporary token which it issues. Generally, this token is valid for a very fixed period of time. You'll have to log in again using the same procedure once the token expires. So once you've logged in, we can see that we can create resources in the cluster. So we'll start by creating a very simple pod. Pod is the fundamental unit in an OpenShift cluster. So what we'll be doing is we'll be creating a new pod from a given image. I'll just walk you through the image now. So this is the pod we'll be creating. We'll be using the Alpine Heshi TPD or Apache image, and then we'll be exposing port 8080. Let's go ahead and create the pod. The command to create a pod is OC apply. You can see that the pod is a YAML file. So I do something like this to add this resource in my system. You can see that I've not created a new namespace or a project for my apps. So let me do that. Okay, now I'm in apps namespace. So I'm using apps, that's what it says. So let me try to create the pod again. You can see that it's trying to create the pod. I can actually look at the logs of the pod. using this command. OC logs -f is to tail the logs of that. Okay, we see that it could not create the log. I'm sorry, it could not create the pod because I get a permission denied. And that's exactly what OpenShift does for you. It doesn't run a container as a root user. So even within the container, you're not supposed to run as a root user. That's a security failsafe mechanism which OpenShift provides you. So it didn't successfully create the pod. So you can see the status here is crash loop back off. So I'll explain in another video how you can bypass this. But for now, just understand that OpenShift cannot run containers as root in the system. So let's try to create a non-root pod. So this is a non-root pod. Why is this a non-root pod? Because it's an official image provided by OpenShift. So it runs the Apache process as a non-root user, except that everything else is the same. So let's try to create this pod. Before that, let's delete the old pod. So there are no pods in the system for my namespace. Okay, you can see that it's running. Now let's try to get the logs again. This time it's going to be successful. So you can see that we have the HTTPD process or the Apache web server running, ready to serve any requests. Now the thing is, we created a pod and that's just it. This pod is not quite useful in itself. It is not exposed to the system. So there's no way we can use this pod in any way. So what we do is we expose this pod as a service so that at least other pods in the cluster can recognize this. So the command to do it is to create a service. So let's see what service we are creating. You can see that consistently I apply this metadata to all the resources I create because I want to tag them all using the app equals demo1 label. So this is a common feature which you get in both Kubernetes and OpenShift. In fact, so far the resources which I've discussed are common for both Kubernetes and OpenShift, the pods, the services, and the routes and all that. So what this says is you expose any pods which are falling under this label app equals demo1 as a common tag. That's what the service does. So you can have multiple number of pods which have the same configuration, which run the same image, which expose the same port. Service is a way to tag them all into a single unified resource. So let's create this service. Again, the command to do that is to apply. So the default way to expose a service is using a cluster IP. This is an IP which is visible only within the cluster to all the other services. So if you do a curl of this IP address inside the Minishift cluster, you're going to get a response for your request. You're going to hit the Apache server inside one of the pods. Now the thing is, there is only one pod which is being covered by this service. If you add multiple pods under the same configuration, they are all going to fall under the same Apache service. Let's try to hit a curl outside the cluster. You might get a timeout. Now what we'll do is we'll try to log in inside the Minishift cluster. I think the command is SSH. Yes. Okay, now you can see that you get a response within the cluster because this service is not visible outside the cluster. So, but real world applications frequently interact with the outside world. So if you want to expose your Apache web server to the outside world, you expose the service as a route. So what you do is OC expose service Apache service. So it creates a new resource called a route. A route is something which is very specific to OpenShift. This was conceived before the idea of a Kubernetes ingress. It's very similar to that. So if you do OC get routes, you'll see that it's created a new route for the Apache service, and this is the domain name which you can access it from. If you've configured your OpenShift cluster with a proper domain name, you're going to get something like example.com here. But because I didn't do that and Minishift is configured to work with nip.io, you'll get this kind of domain name. So let's hit that. So this is the same response we got when we did a curl inside the cluster as well. So we've now seen how a route works, how a service works, and how a pod works. Now the thing is, you won't be directly creating pods in your system. You'll be creating a service which will tag all these pods, and you'll be creating multiple pods of the same configuration. So let's try to create a set of similar pods which have the same configuration. Like for example, I'm going to create another pod with the name Apache 2, which has the same configuration, and illustrate the point that a service is going to serve from either of these two pods. So currently we have only one pod. Let me create another pod with the same setup. Okay, how do I know that my service is serving from both these pods? What I do is I check my service to see whether it's hitting both the endpoints. So the describe command actually shows you what all metadata the service contains, what the service exposes and all that. So you can see that there are like two endpoints here. Each of these endpoints represents a pod. I created another pod with the same configuration, the same label app equals demo. So this is a selector for your service to find out which pods it wants to tag. So I've created two pods with the same app equals demo configuration, and now it tags both these pods together. Let me delete both the pods. You're going to see that the service is not going to serve any requests anymore. So OC delete pod Apache. Apache 2. And now if you describe the service, there are no endpoints, and if I hit the route, I'm not going to get anything. So it says that the application is not available. It's very common for pods to go down in a cluster. So you have to always ensure that your pods are always running. One way to do it is to create something called a replica set. Replica set is another resource in the OpenShift cluster. It is very similar to your Kubernetes replica set. So a replica set says to OpenShift cluster that, hey, always maintain a fixed number of pods which match this configuration in my cluster no matter what. So even if the pods go down, your cluster is going to keep a watch on that pod and then bring it up again. So let me clean up my namespace first. So the way to do it is OC. Before that, yeah. I'll walk you through what a replica set is. A replica set, as the resource name denotes, it's going to create replicas of your configuration. So this is the configuration I've given here. Same web server. This is the image I've given. I'll talk later about why I've created a custom image here. For now, just understand that this is going to run Apache as a non-root user, and this is my selector. It looks more sophisticated than the app equals demo one because a replica set allows me to do that. And I create 2 replicas of this specification always in my system. So let me go ahead and do this. So let's confirm that there are no pods in the system. So you can see that it has created 2 pods here. There is a random string appended to the end of the pod, and they are in ready and running status. So now if I describe the service, it has 2 endpoints running. The reason why the service catches these pods is because they match the app equals demo configuration. You can see that in the replica set. I have the app equals demo 1 label for the pod which I create. So let's see how replica sets exactly work right now. So to ensure that the replica set is already created, I can do a OC get replica set. So this is the desired number of pods I want in the system, and this is the current number of pods I have in the system. And it's been running for the last almost 1 minute. So let me delete a pod. Okay, I deleted a pod and it immediately created another one which is running for the last 7 seconds. You can see that the other pod has been sticking around because I didn't delete that. So no matter how many number of times you're going to delete the pods, the system is always going to bring it up because replica sets keeps a watch on the pods which match this label. So it's always going to ensure that you have 2 copies of the pod running in your system so that your app never goes down. So you can see that it's beginning to serve the requests right now. The reason why we get a different output is because I use a different image, which I do to illustrate the concept of a deployment. So let's move on to the idea of a deployment. Deployment is another resource, which is an abstraction on top of a replica set. Deployment is something which is very deployment config is very specific to OpenShift, and the idea of deployment is there in both Kubernetes and OpenShift, but it was conceived first in OpenShift. So why do we need a deployment? The reason is, let's say that I want to deploy a newer version of my containers. Let's say that I have a V2 running. I need to destroy this replica set and then create a new one. No, that's not exactly fun, because every time you have to modify this configuration and do a lot of things. It would be great if this whole thing is automated, in the sense that whenever OpenShift detects that your image has changed, you can deploy the newly created image into the replica set, and then you can see it deployed immediately. One way of doing it is to build an abstraction on top of a replica set called a deployment. I'll walk through what a deployment is. It looks very similar to replica set. It's called a deployment config in OpenShift and a deployment in Kubernetes. So it is the same as a replica set. It maintains 2 replicas of your specified container, and this is something which is new to the deployment config. So it says triggers. So it's going to trigger a new deployment whenever there is an image change. So what is the image change we are looking at? So whenever the Apache image tagged latest changes, your cluster is going to deploy a new copy of the replica set. So let's see how that works real quick. You can see that the new deployment config is created, and it is triggered by an image build. Now, when I say image, I mean a container image, but that's not entirely true. So you can see that the current status is 0 because it didn't find any image here. So let's trigger an actual deployment here. The command to do that is OC rollout latest deployment config, your deployment config name. So this latest has nothing to do with this. This is a tag name and this is a command. So rollout is going to create a new deployment or roll out a new deployment, and it's going to do a latest deployment here. So if you type rollout help, it's going to show you what exactly it means. So latest is going to start a new rollout for the deployment config with the latest change from it triggers. So I try to do this and it fails because it's not able to find out the image which I specified in my deployment config. So it says that Apache latest should trigger a new deployment, but Apache latest is nowhere to be found in my system. The reason is OpenShift maintains internally a concept called image streams. Image stream is just an internal version of your images, which is maintained by OpenShift. Now, why would we want to maintain an internal version of the container images instead of pulling it from a public registry? The reason is you want to maintain consistency of images. I'll do a deep dive into the concept of image streams later, but for now, you just have to understand that you have to maintain consistency of the image tags and versions inside the cluster, within the cluster, and you can trigger automatic deployments based on changes in image streams, and you cannot do that when you change images in an external registry. So there is a resource maintained by OpenShift for that. It's called image streams. So you do OC get. There are no image streams right now, and that's fine. So what we do is I've already built a new image here. You can see that there is a directory called custom image, and I've created a new image from this using existing OpenShift official Apache image. It just prints out the version number in an index YAML file. So there are 2 flavors of it, V1 and V2. V2 is going to print V2 and V1 is going to print V1, just to show that there are different versions. So I've built this image right now, and I want to tag this or bring it into my image stream. So the command to do it is OC. Let me do it here. OC tag source docker, my image name. This is the namespace of the current project which I'm using, which is apps Apache latest. So what it does is it tags this external image as Apache colon latest in my image stream. So once I do it, if you get all the image streams, you'll see that it is the Apache latest tag. So once you get a deployment config right now, it would have triggered a new build. So you see that current is 2 instead of 0, because I created a new Apache latest tag and it triggered a new build. Now when you hit the endpoint, you're going to see hello world version 1. Because I've deployed version 1 here. Now let me tag version 2 as the latest image. It's going to create a new deployment. So you can see that it destroys and creates pods to match the new deployment or the new image. And if you refresh this, you're going to get the new image here. Let me recreate the whole thing. I think I have to delete the replica set before I... Or rather, let me delete all the apps. Okay, it deployed version 2 here. It was showing version 1 earlier because it was taking into account the replica set pods as well. So we learned how image streams work to some extent, and then how a deployment config works, how a deployment gets triggered, how pods gets created, how they are exposed as services, and how services are exposed to the external world as routes. In the next video, we'll be looking at how to create apps in a more robust and a scalable way and improve the developer experience. Until then, stay tuned. Bye-bye.